Welcome to the Kubernetes and GKE practice series from the AI Mock Interviewer Question Bank. Kubernetes and GKE Part 1. This episode has 12 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. GKE or Kubernetes? Configuration drift. How would you detect and prevent configuration drift across applications, clusters, and cloud infrastructure? Here's a strong way to approach it. Detect drift by running scheduled Terraform plan jobs against live infrastructure and diffing actual Kubernetes cluster state against the GitOps declared state. Argo CD or config sync surface this automatically, alerting when a diff appears rather than discovering it during an incident. Prevent drift by making the deployment pipeline the only path to production. Restrict console or manual access for routine changes, and force it through IAM. And treat any manual emergency change as something that must be reconciled back into source control immediately afterward. Nice. Let's continue. Question 2. SRE or reliability? SRE fundamentals. Design and slow for a customer-facing API running on GKE. What sleaze would you choose? How would you calculate error budget? And how would it affect releases? Here's a strong way to approach it. Choose sleaze that reflect real user experience, request success rate, non-negative 5xx responses, and latency, e.g. page 95 under a threshold, measured from as close to the user as possible. Load balancer metrics, not just app internal. Set the slow target, e.g. 99.9% success, based on business impact of failures. Calculate the error budget as the allowed failure volume over the measurement window, and use the remaining budget to gate release velocity. Healthy budget means ship freely. Depleted budget means slow down and prioritize reliability work. Great. Moving on. Question 3. Observability. Cloud monitoring. How would you design alerting policies in Google Cloud Monitoring to reduce alert fatigue and focus on user impact? Here's a strong way to approach it. Alert on symptoms that directly indicate user impact. Elevated error rate, latency breach, slow burn rate, rather than every underlying cause, and use multi-window burn rate alerting so fast. Severe budget consumption pages immediately while slow. Minor consumption creates a lower urgency ticket instead of paging. Route every alert to a specific owner with a runbook link, and periodically prune alerts that fire without leading to action, since those are the ones training people to ignore pages. Alright, next question. Question 4. Networking. Ingress controller. How would you debug an ingress path returning 404 or 502, from DNS to load balancer to ingress controller to service endpoints? Here's a strong way to approach it. Work through the chain in order. Confirm DNS resolves to the expected load balancer IP. Check the load balancer's backend health status. Unhealthy backends often produce 502s. Verify the ingress resources host or path rules match the request exactly. 404s are frequently a path matching mismatch, and confirm the service selector actually matches running. Ready pod labels. A 502 specifically often means the LB reached the ingress controller but the ingress controller couldn't reach a healthy backend pod, so checking pod readiness is usually the fastest way to narrow it down. Let's keep going. Question 5. Security or DevSecOps. Kubernetes secrets. How would you compare Kubernetes secrets, secret manager, external secrets operator, sealed secrets, and CSI drivers? Here's a strong way to approach it. Native Kubernetes secrets are only base64 encoded, not encrypted at rest by default, and live in eth, so they're the weakest option alone. Secret manager is the source of truth for the actual secret value with proper encryption, access control, and rotation. External secrets operator syncs secret manager values into Kubernetes secrets automatically so apps can still consume them natively. Sealed secrets lets you safely commit encrypted secrets to Git, decrypted only by the in-cluster controller, and the secret manager CSI driver mounts secrets directly as files without ever creating a Kubernetes secret object, avoiding eth exposure entirely, generally the most secure pattern for GKE. On to the next one. Question 6. CI or CD or GitOps. Pipeline caching. When can ML pipeline caching help, and when can it hide stale data or bad assumptions? Here's a strong way to approach it. Caching helps when a pipeline step's inputs genuinely haven't changed. Rerunning an expensive feature computation on identical upstream data wastes time and money. It becomes dangerous when the cache key doesn't actually capture everything that affects the output. For example, caching on code version alone while the underlying data silently changed, which can serve a stale result that looks like a successful run. The fix is making cache keys include every meaningful input, code, data version, config, and treating cache hits as something to occasionally spot check, not blindly trust. Good. Here's another one. Question 7. GKE or Kubernetes? Go services. If asked to build a Kubernetes controller or CLI in Go, how would you approach the design even if Go is not your primary language? Here's a strong way to approach it. Lean on established patterns rather than inventing your own. Use controller runtime or kubebuilder for a controller. It handles the reconcile loop, informers, and leader election scaffolding, and Cobra for a CLI. Standard flag or subcommand handling. Focus design effort on the actual business logic, what the reconcile loop needs to converge toward, what the CLI's core commands do, and rely on Go's straightforward syntax and the framework's conventions to fill in the rest, treating it as learning a new tool rather than a fundamentally different way of thinking about the problem. Nice. Let's continue. Question 8. SRE or reliability? Reliability review. What would you check before certifying a service as production ready on GCP or GKE? Here's a strong way to approach it. Check that slows are defined with corresponding alerts. The service has health checks, readiness or liveness correctly configured, resource requests or limits are set appropriately. There's a tested rollback path and runbook for common failure modes. Security basics are in place. Least privilege IAM, no hard-coded secrets, workload identity, and on-call ownership is assigned. A production readiness checklist should be concrete and verifiable, not a vague looks good to me sign-off. Great. Moving on. Question 9. GKE or Kubernetes? Kubernetes architecture. Explain the architecture of Kubernetes, including control plane and worker node components. Here's a strong way to approach it. The control plane consists of the API server, the front door for all cluster interactions, stores cluster state, the scheduler, assigns pods to nodes, and controller managers, reconcile actual state toward desired state. Worker nodes run the kubelet, talks to the API server and manages containers on that node, a container runtime, and kubeproxy, handles service networking. Together the control plane decides what should run and workers actually run it. Alright, next question. Question 10. GKE or Kubernetes? Kubernetes workload objects. What are pods, deployments, replica sets, stateful sets, and daemon sets? Here's a strong way to approach it. A pod is the smallest deployable unit, one or more container sharing network or storage. A replica set ensures a specified number of identical pod replicas are running. A deployment manages replica sets and adds rolling update or rollback capability on top. A stateful set is like a deployment but gives pod stable identity and storage for stateful applications. A daemon set ensures exactly one pod runs on every, or a selected subset of, node, typically for node-level agents like log collectors. Let's keep going. Question 11. GKE or Kubernetes? Stateful set versus deployment. What is the difference between stateful set and deployment? Here's a strong way to approach it. A deployment treats its pod replicas as interchangeable and stateless. Any replica can be replaced without consequence. A stateful set gives each pod a stable, unique network identity and a persistent volume tied to that specific pod ordinal, so replacing pod 1 gets the same identity and storage back, which is required for workloads like databases where identity and data continuity matter. On to the next one. Question 12. GKE or Kubernetes? Kubernetes service types. What is a service, and how do cluster IP, node port, and load balancer differ? Here's a strong way to approach it. A service provides a stable network endpoint and DNS name that load balances traffic across a set of pods matching a label selector, decoupling clients from individual pod IPs that change as pods are rescheduled. Cluster IP, the default, is only reachable inside the cluster. Node port additionally exposes the service on a static port on every node's IP. Load balancer provisions an external cloud load balancer, e.g. a GCP network or HTTP/SLB, that routes external traffic to the service. Good. Here's another one. That wraps up this episode. Nice work practicing, and see you in the next one.